Okay. Um, can you hear me okay? Are we starting now? Perfect. Great. I guess I can start now, right? Can you? Shall we start now, or shall we wait a bit? Okay, great. Thanks. All right. So, good morning, everyone. Thanks ever so much for your time. In this session, we will be talking about machine learning and computer forensics. Most specifically, we try to sort of combine it with a tool I built called Colombo. Um, so yeah, so let's get started with it. So first of all, who am I? My name is Alan Saied, and I work as a security and machine learning architect at Visma here in Norway. And what that really means, I do quite a lot of security in the context of machine learning. Okay, I'll do that. And I work as a security researcher and a data information analyst. And basically, again, I work quite a lot with data in order to understand, behaviors. I've recently implemented this tool called Colombo, which is mostly used for forensics purposes, computer forensics. And as I pointed out earlier, the talk is going to be around this tool mostly in combination of how machine learning, pattern recognition, as well as pre-processing being combined together. If you want to contact me after this session for any questions or anything like that in relation to this, session in relation to this topic, please use my email or LinkedIn account. More than happy to respond. Right. So what is the agenda for today for this session? I try within 45 minutes to cover the following topics or sessions. First of all is the objectives rather. What is it that we're trying to say? What is the purpose of this presentation? And since we're talking about machine learning in the context of forensics or digital forensics, I thought it would be interesting to give a very brief definition of digital forensics. Combine that with machine learning and why we have chosen machine learning as part of it. And also then we slightly and deeply, I should say, go through Colombo, the features of Colombo, and also why do we get sort of false positives when we use machine learning in general, and specifically when it comes to Colombo itself. We're going to have a demo of Colombo to go through its features, and also we will be using two or more or couple of memory images, as well as some file systems to go through them. Then we go through the pros and cons of Colombo and how and why do we get biased machine learning models, and as a result of that, how that going to fool users in using machine learning models in various different applications. So yeah, within these 45 minutes, I'll try to cover all of these topics. So objectives. The purpose really of this presentation is to share my experience with when it comes to machine learning and computer forensics, and sort of encapsulate that in Colombo. So in a form of demonstration, I will sort of demonstrate how Colombo can assist forensics examiners in identifying digital evidence. Furthermore, you will, as I pointed out earlier, you will know the features of Colombo when you run it, and how is that actually assist your entire forensic process. Towards the end, we will talk about whether we should trust machine learning or not. And if so, why do we get false positives or false detection when it comes to this particular, technology or science? So yeah, so let's start with the very basic definition of digital forensic for those who don't really know much about it. I have completely copied this definition from this reference below. So it says digital forensic science is a branch of um, forensic science that focuses on the recovery and investigation of material found in digital evidence related to cybersecurity, cybercrime. Now, what does this mean? If we explain this in a context of a use case, let's assume a set of computers are compromised at your organization by a set of, by some criminals. As a result of that, or during or after, some alert and detection happens, and the incident response team will take some actions. And one of the actions they take is to gather evidence. Mind you, this process from left to right is a very simplified sort of version of incident response team actions. And I sort of simplified it for the purpose of this presentation. But in reality, you have got a lot of elements in between, different boxes and actions. But the most important thing in relation to this presentation really is the gather evidence. So what do we mean by this? So when an incident happens, the incident response team will gather some information like log files, network traffic logs, those infected files if they can find, and some memory images. So these files and these information are vitally important. Why is important? Because we want to know how did this breach happen, how the criminals managed to penetrate in, what kind of approach they used, what was the weakest link? Was it a human error? Was it something to do with the infrastructure? Was it something to do with a misconfiguration, or was it application? And we want to know whether there were any involved parties, someone from the organization itself, whether any agencies were involved. Now, these information, again, we need them because we may or may not use in the court of law at some point. On the other hand, we want to learn from the mistakes, patch this problem, whether it's infrastructure related or application or human error. So that's why digital forensic is, vitally important to have it in any organization. Now, when you work as a digital forensics examiner, you face quite a lot of challenges during the investigations. And typically, a digital forensics examiner use many different tools during the investigations. But one of the biggest challenges that they face is the amount of overwhelming data and information that they get. So that information is so huge, sometimes evidence can actually be hidden or even difficult to find. And as a result of that, confusion might happen. And also, it can be very time consuming. So this is going to be even harder where you are under pressure and you actually need clues to know how this whole thing happened. Now, if I put myself in this confusion, this actually happened to me last year when the nasty COVID started spreading around. Like anybody else, actually, I was working from home. And one day, I was working on some memory images and files. And the amount of data and information were generated by those third-party tools were huge. And that created a huge amount of confusion for me. And this is when the whole thing started. I was, telling myself if it's going to be a better way to sort of simplify this, and this where the whole idea started. And I was, talking to myself, saying, what if we use the same forensics tools that we have to extract the information, and then the information and the data, and that data automatically pipe into an automated or semi-automated pre-processing and machine learning engine. So coming from a machine learning background, I thought that would actually make a lot of sense. You just need a third-party tool to extract these information from the memory image, from the file systems, and all those compromised devices or sections, and automatically organize them and pipe it into an engine. We use machine learning to, first of all, simplify this process by breaking down the entire data set into smaller sections. And furthermore, we can use this to assist the examiner, the forensics examiner, and create some sort of a suggestion to identify the evidence. So, you get a suggestion, say, so maybe this directory is suspicious, maybe this is genuine. And we can add more new features like process traceability and many more. Now, since we are dealing with machine learning, again, I thought it would be interesting to give a brief explanation of what we mean by machine learning, and specifically in the context of Colombo. Again, this definition I've copied from this link. It says machine learning is a data analytics technique that teaches computers to do what comes naturally to human. Learn from experience. Machine learning algorithms use computational methods to learn information directly from data without relying on predetermined equation as a model. The algorithm improves their performance as the number of sample increases. Now, if we take some important words out of this definition, we see data analytics, teaching, experience, improvement, all these, keywords. But let's further simplify this definition into these boxes. By now, I hope everyone knows that machine learning requires data, and data is the backbone of any machine learning models. Without data, you don't have no models, and most likely you don't have predictability, classification, or even automation for that matter. But what is data? Data basically it contains the characteristic features of an event, a scenario, or an example. So for example, in the context of Colombo, we have a set of information that describes a sort of a suspicious behavior. We have another set of information that describe a set of genuine behavior. And we have all of these data structured in a way for the machine learning algorithm to understand, or the model to understand. So in another word, we teach the model all of those behavior. And in a supervised manner, we tell the model, okay, if you come across these kind of behavior, chances are they are suspicious. If you come across these behaviors, chances are they are genuine. But in order to do this learning process, we need to have some algorithms in place, and these are called the learning algorithms. And this is the methodology which basically mathematically learn all of these behaviors that we have in the data set. And as a result of that, you would get a set of models. And these models, we use it for different purposes. For example, we use it for spam detection. In the context of Colombo, we use it to identify and predict where exactly the compromised directory and whether this command was actually a genuine or not. So yes, this is the very simplified version of machine learning. You need data, you need machine learning algorithms, and you have the models. Now, if we further sort of analyze or decompose those three boxes, you actually have to do other steps. So when you have the data, you need to pre-process and organize and correlate, sometimes correlate these data. So you have to take some other steps. And depending on what kind of data you have, you need to convert them into numerical representations. Because machine learning and computers, really, they don't understand male and female address or email address or anything like that. Everything has to be in a numerical format. So we need to convert all of these. And then we pipe it into a set of machine learning algorithms. It could be in a supervised manner, so we teach the actual model what to do in a learning way, or unsupervised. We frankly tell the model, okay, this is the data. Can you make sense of it? And as a result of that, you have a model or set of models which may or may not be ready for production. But to verify this process, we need to use some statistical approaches, as we're going to talk about it towards the end of this session, of how you're going to do this. And these statistical approaches will be used to verify how accurate your model is, how good your model is, whether it is whether it is whether we should deploy it to production or not. Um, and then if you're happy, you go out, everything is good. Otherwise, you go back to point one and try to, change the data, reorganize the data, try different approaches, tweak the learning algorithm until you're happy. So this is a sort of machine learning life cycle, put it this way. Now, this was really the definition of and a short explanation of machine learning, which is related to what we're trying to do in relation to computer forensics. And this whole thing, if we combine pre-processing, machine learning, and pattern recognition, this is where Colombo was born. And by the way, I called it Colombo because it is based on Detective Colombo. It's a nice series, so I thought, why not? Now, if we define Colombo in this very short definition, we could say it's a computer forensics tool. The main purpose of this tool is to simplify and identify specific pattern. So first is that we're trying to do a simplification. In another word, when you have this huge amount of data, we want to make sense of it and break it down into smaller pieces. And as a result of that, we can apply some approaches, including machine learning, to identify patterns in a compromised data set. So we apply pattern recognition and machine learning to identify the behaviors. We try to classify or predict where exactly this compromise happened, just in a form of assistance, really. Now, the features that you get out of Colombo at the moment, for now, this, what we have is the beta version, and we are improving it as we go along. But for the time being, it only works on Windows environment. There are plans for Linux and Mac. First of all, it will try to analyze the machine where the malware is actively running. This is a big statement. So what we're trying to do here, if for the sake of the argument, you have a malware running in the background, we use third party to extract relevant information, running processes, and we feed these information to a machine learning model, everything encapsulated in within Colombo itself. This is one of the options. It will try to identify where exactly or which path it might be infected. Now, with this, we may or may not get quite a lot of false positives. And I'm going to talk about it as we go along, what we mean by false positive, depending on what kind of data we have used. Furthermore, it can investigate Windows hard disk image in files and memory images of Windows machine. Once we get all of these data, then we pre-process the information from all of these third-party forensic tools, and we try to identify and suggest the infected directory. And when I say we, I'm referring to Colombo. And the executable command in a form of suspicious or genuine. And this is very important to emphasize when we say suspicious and genuine. Because think about, let's assume you're a forensics examiner. When you look to a path or a command, you may or may not think this is suspicious depending on your experience, but you only know the absolute answer when you take your investigation further. That's why Colombo, it actually suggests that whether this is suspicious or genuine, because it's trying to assist you to take this to the next level. And it will try to group all the processes according to their mother processes. We will get into that, what I mean by this, and trace each processes all the way back to their root process combined with the time of executions. And this is quite important if you're a forensics examiner, because you want to know when a process has been executed, whether there's any time interval. And these information can be used in a court of law if required. Each process responsibility, whether this process is responsible of executing other processes or not. So all of these information are encapsulated or combined together when you search for a specific, let's say, process ID. A little bit more about what we mean by Colombo and machine learning. Again, Colombo uses data pre-processing to organize the data, and machine learning models to identify suspicious behavior. Its output in a form of 1, which is suspicious, or 0 to be genuine. Again, I mean, this is a binary classification method, but we are using suspicious and genuine. And this is, this is in a form of suggestion, purely to assist the digital examiners in their decision making. So remember, we're not trying to replace digital examiners by an application, but we're not trying to replace the existing tools. In fact, we're using the existing tools to extract the information and assist the examiner to speed up and automate the process. And this is, we will further understand it as we go along. There is one big problem when it comes to forensic, computer forensics in general and machine learning, which is false positive. It's nearly impossible to eliminate that problem. You can reduce it, but you cannot eliminate it. No matter what, you will get false positives. But why do we get? The question is, why do we get false positives, especially when it comes to machine learning? In the context of machine learning, this is all relies on what kind of data and the quality of data that we have used to train the model. And what I mean by this, for example, if we take Explorer, binary, a native Windows executable file, that native executable file can be used for suspicious activity, but at the same time, it can be used for genuine activity. So from the machine learning's point of view, from the data point of view, we actually fed the model with different possibilities. And in some of those possibilities, that, for example, that particular executable file is used for something really good, and it's required by the machine. On the other hand, the same thing can be used by the attackers to manipulate certain executables. And when we go through the demos, I will further explain it of what I mean by this. So it is nearly, it's very difficult to minimize that impact. However, to assist the forensics examiner, I generated something called the percentage score, which helps the examiner to make the right decision or the appropriate decision for that matter. So if you get a path to be suspicious, next to it, we will have some scoring by 60%, 70%, 50%, probability or certainty to think, okay, this is suspicious by 60%. And again, we will get into that as we go along, how you can use these features as part of the investigation. Yeah, so that would help you to pick and choose the path and the command required for this. Let's get into the demo now. So you need some dependencies, and these dependencies are volatility 3, auto-run C, and SIG-check. So if you are a forensics examiner, you know these tools. They are fantastic tools. But in the context of Colombo, we use these third-party tools to extract the data from memory images, from file system, and things like that. And please make sure when you read when you download them, or before you download them, you read their license agreement before you put it in the right and applicable directory of Colombo. As part of the demo, we have some images, a couple of images. One of them is old, and the other one is fairly new. This one is actually, it was from a ransomware attack that launched on Visma 2.5, I think it was 3 months ago, if I'm not mistaken. And the memory image is from patient zero. And we use that as an example of how Colombo actually assists the whole process of identifying where the whole thing started from, patient zero. Yeah. And then we have another file system which is not the same. It's a another unrelated infected file system, which you're going to use it for this demo as well. Now, if you want to know about that attack, which was launched on the ransom attack, which was launched on Visma, please go to YouTube and search for Visma security conference. Over there is a talk by Ula Williams where he talks about that in much more details. But this is actually the technical part of it. Okay, let's get started. So this is the directory. So if this is the binary version of Colombo, the first thing you need to do really, you need to go to the bin directory and download these files. Are they big enough? Or is it? Can you see them? Yes, no. Okay, no answers. Anyway, so you go there and good, thank you. So under there you have volatility 3 masters, and under volatility you go to, well, masters, you go to volatility, and further you go to symbols. You need to go to the volatility GitHub. On the GitHub, go to volatility, and you need to download Windows 3. Under Windows 3, you have the PDB file. So make sure, please, you have the entire path as Colombo bin volatility 3 master volatility symbols at Windows, and followed by these files. And this is required, by volatility in order to extract the data properly. Now let's go back here and let's run this. Now, when you run Colombo, straight away you get a menu of 4 options. The first one is not that important. I mean, it is important because you need to read the license and the guidelines and anything that you want. The second one is about the life analysis. The third one is scan any file systems. And then you have the memory image. So I'm going to start with the memory image of an old memory image that I have, just for the purpose of demonstration. So I'm just putting the path of the memory image, and I press. If you want to know, I mean, some examiners really want to see the memory image information, and in here I'll just press yes. So this gives you some memory information. Again, we use volatility 3 to extract these information. Some, as I said, forensics examiners use these information for whatever purpose. I personally don't use it that much. But the interesting part is when you do the process scanning. If I press yes, then what it does, Colombo will try to cluster or group all the processes within that image that we have here for testing, as you can see here, according to their mother process. So it says this process is responsible of executing these processes. This process is responsible of this, and all the way down. For example, this process is responsible for these processes. As you can see, there's a dodgy looking process here, which we may need to investigate further and learn more about it. Now, again, we use third-party third-party tools to extract the data, and Colombo clustered all of these accordingly, all of these information accordingly. And this is important if you're an examiner, because you want to have a better look of where exactly and who is responsible of what. Now, if you think the above output is not nice, you can actually say yes, and you would have a notepad version of this, and you can use it later as part of part of your investigation. And while this is happening, Colombo will try to, using the third party, to extract, to use DLL list files and handles, which will be using it for process traceability afterwards. We will get into that section later. Now, some examiners would like to have a process tree. This is, again, a feature of volatility which you are using it. But again, all of these information that you will get here will be used by Colombo in order to make appropriate decisions in terms of finding the actual compromise directory or file or commands that have been used. If we want to know about the anomaly detections and further information about that, again, third-party tool used to get the information when we have some kind of anomalies, which was generated by volatility. But here, what we are doing, what Colombo does straight away after getting all of these information from the top, as we seen earlier, it tries to make some decisions and say, okay, the malware is actually located in this directory. So it's under document and setting, administrator desktop, and that's where the malware is. The output is 1, which looks suspicious, and it gives a huge certainty of 100%. That's very certain this is the malware. Now, if we go back up, or in fact, if we use the output from here, what we have seen that this is actually that executable file, and it was executed by that. So what I'm going to do, I'll take this process ID and further do some investigation. So first of all, Colombo will try to find the command which was associated with this executable file, but it didn't find it. But instead, it found the process traceability. So it says this process was executed by Explorer, and that process is executing the command line. Now, as you can see, in a very short amount of time, Colombo uses the existing information that you get, straight away use those information in order to make some decisions to identify where the actual location of the executable file is. Now, this is a very simple example. Let's get into something really complex. In another word, let's talk about the ransomware that we had 2 months ago. This is the memory image of patient 1 that we have. We've called it incident 001. So Colombo will upload this. I didn't go into the memory, information, anything like that. Now, just one, small note. The reason I have done this prior to the actual presentation, because the file, this dump file, is really big. I think it's roughly about 20 gigabytes or something. And to extract these information from that memory image, it takes roughly about 15 minutes. And since I have 45 minutes to present the entire thing, I thought it would be faster to do it in advance and show you only the output accordingly. Now, just like before, if you want to do the process scan, you press yes, and I think you should, because if you don't do it, then you can't get process traceability, and the model cannot find how the whole path. But as you can see, the Colombo clusters all the process in relation to that incident into groups. And you can see you have a lot of processes running. I mean, just this process is executing so many other processes. This one is executing more and more processes if we go down. And this is what I mean by you are actually overwhelmed by data and information. Because imagine if this just a raw data and you see it, you actually get very confused of which process is responsible of what processes, and that will give you a very good and nice structure of all the processes. And now, as you can see, this computer is very busy, or it was very busy, I should say. So many processes were running, so many applications were running in the background, and I wonder why. But we are still experiencing more and more and more processes to be run. But again, Colombo is clustering each of them according to their mother process, and these are we keep going, process after process, and yeah, we get into a certain point. Again, like before, if you want to see these above information in a form of notepad, yes, you can say yes, and you will get that. Colombo will get all the DLL and handles in relation to all of these processes, which will be used afterwards to see whether this is a genuine or suspicious. Any of them are genuine or suspicious. Now, volatility gives you some outputs, some anomalies, and quite a lot of times these anomalies are not correct. But again, we chose to give these output back to the user to use it if they want to. But most importantly, these information will be used later. And start to do some investigation to the anomalies. And so I started with this process ID, maybe I should say. This process ID, Colombo straight away says possible process path is command line. Okay, and then Colombo says at the same time, the machine learning said that this is suspicious, which is really weird. Why a command line is suspicious? And it's giving a certainty of 61% suspicious, while 38% is not. It might be genuine. But furthermore, it gives more clues about this process itself, and it gives the entire process traceability. And it says that process, which is the command line, was executed by the print document and executed by Chrome, Explorer, user init, WinLogin, Chrome, and admin application. This application all of a sudden was responsible of executing all of those things all the way back to the command line. But still, we don't know why this is considered to be suspicious, why the model sees this as suspicious. Let's dig in further, and that is actually automatically done by Colombo. What it does, it says this process ID, which is this one there, is the parent process for the following processes. So it is executing all the other processes. Now, if you're a digital examiner, you know straight away that this process and that process can be used for genuine activity by the operating system or by any genuine application, but it also can be used by the attackers to actually perform any kind of attacks. So what I did after this, I took this process ID of this one there. And when I do this, Colombo straight away, I didn't found the path that is related to this. And it gives a complete suspicious flag for that path. And it says, okay, this path is suspicious, and the certainty or the probability of this suspicion is 82%. All of a sudden, the whole thing makes sense. First of all, let's look at this command itself. This native Windows process, as I said, this can be used for normal activities, genuine activity, but it also can be used for suspicious activity. In this case, it's used by suspicious activity. So it straight away identified this DLL file to be suspicious under the temp directory run by a user support. Okay, so that makes sense. So a user support user, I beg your pardon, somehow probably done something which led to this happen running in the background, and Colombo identified this to be suspicious. Now let's go further, and see how Colombo encapsulate everything in the context of traceability. let's go back here and we see that admin application is executing Chrome, and Chrome is executing WinLog, and WinLog is logon, and that is executing user init, and from there to Explorer and Chrome and print document, okay, which executed the command line, and the command line is executing this, and that is executing the malware here, and hence this is suspicious. And all the way, if you go back of this actually makes sense why Colombo considered this command line to be suspicious, because this command line is responsible of executing this, which is then res responsible of executing the DLL. And that's the malware at the background. Now, as you can see, if we slightly go back up, or maybe I should say, if we look at this, you get a huge amount of information generated from this memory image, from the file image, from process IDs, executions, and sometimes from the anomaly detections, and all that kind of thing. And it is difficult, at least for quite a lot of examiners, to identify where the problems are among all of this. Again, what Colombo is trying to do is to separate all of these information, and in a form of yes or no, it produces and it tries to find where the suspicious and the traceability, and it gives the examiner some hints where to start, what you should do, and that will give you clues. It's a very organized way of doing the whole thing. Now let's take this into the next level. Now we know that this is the malware, and it was done by a support user, probably doing something, probably an email came or probably something else came and accidentally clicked on it, and that led to this whole entire execution. But then we have other things. If we search for this, we get this, and Colombo sees this to be suspicious as well. But it might not. But why this is suspicious? Because we don't know. It might be suspicious. But think about it from the forensics point of view. Let's assume Colombo doesn't exist and you see this. When you see it, you straight away think, okay, this looks dodgy. Why, but it's dodgy from the point you see it. But you need to further investigate this. Now, if we look closely, it says 98%. But why? Because it uses the same path that was used to run the memory. So what we need to do at this point, or if you're an examiner, you need to do further investigation and decode this. This might be genuine, actually, or it might be suspicious. We don't know. But what we know, that process is responsible of executing so many other processes afterwards, and is running so many things. So it might be genuine. We don't know. It might be just something else. But the idea is to identify, uh, everything as much as possible based on the previous information that it had. Now, this is one part of Colombo. Let's get into another part of Colombo, which is this one here. In here, we're using option 2. And in option 2, we do a live analysis of files and processes, and we do some sort of a traceability there. What it does, it tries to analyze, again, it uses a third-party application to extract the running processes, but then it tries to find patterns which they look suspicious. And I see something suspicious here. By the way, this is a test computer, so I have some stuff in the background for testing purposes. So yeah, and this actually, it looks like a hidden VB script and run to hide and all that. So it straight away identify these things. And furthermore, it tries to identify services running in the background, and it sees them as suspicious. One. However, if you look at these processes, you may think, why this one is suspicious? This is very genuine. And why is giving it 1? And this is where the certainty and probability play an important role. Here, we can see that the model gives 50%, 50.5% certainty for this to be suspicious. It's not a big percentage value. And it's the same thing in here. You can see it's giving 61. Again, it's not that high in if you compare it to the other one. It's still a figure, but it's not very high. But why Colombo identified this from the first place to be suspicious? And that is related to the data that we have used to train the model. In the data, we have scenarios and situation where SC is actually used for suspicious activities. And we have scenarios where SC is used for normal activities. And depending on the information that it gathered and had, it used, it identifies this to be suspicious, but at the same time is giving a very low percentage value. And this is the moment you, as a forensics examiner, you have all the information in front of you. Colombo will give you clues and hints for you to make the right decision, whether you should continue investigating this or this or even that, or whether you should drop it. So that's one of the options. But if we go furthermore, we can actually examine the running processes as we go along. Now here we have so many, again, it takes all the running processes and it will try to figure out whether they, clusters them accordingly and see whether they are suspicious or not, to see, to actually have a better look or not. And then we can take, if you take, for example, this process ID, because this looks a bit weird, and further investigate it and see what is this. I just need to put the process ID. And then Colombo says this service is associated with this command, but this command is genuine, nothing to be worried about it. Furthermore, this process is executed by this process and this process and that, and which has the root process. And each of these don't actually have any commands associated with this like that one. So as you can see, it's trying to group all the processes running on the machine, and at the same time, it tries to make sense of it and identify where the suspicious activities are. Another feature of Colombo, oh, that's not the one. Okay. Not this one either. It's probably this one. Yeah. So if you have a file system that's mounted, Colombo can actually use the third-party applications. I think I'll minimize this a bit so you can see everything. Yeah. So it tries to it extract all the relevant information. And in here, we're using pattern recognition, really. We're not using machine learning. So we use the verified machine type publisher and some sort of a description in relation to virus total detection, which is, again, some features of SIGCheck, to extract all of these unsigned running files in relation to this mounted directory that we have. And by the way, this is an infected mounted directory. And then Colombo kicks in. It completely ignores all of these patterns because it sees them as irrelevant. It only focuses on the relevant ones and identify this and this to be suspicious and is giving one. And when we did the investigation, we actually learned that these are written in Go language, and there were actually some really mild viruses, not something that we should be worried about. But again, what is really interesting, if you go back up, the virus total identify them to be, the pattern recognition identify these to be unsigned, but the virus total identify them to be unknown, while Colombo straight away ignored all of these and focused on the one that that are relevant and labeled them as like that. And when it comes to if you think these outputs are kind of confusing, Colombo generate an Excel file of all the paths and the suspicious path and the machine learning step 3 result directory where you have installed Colombo. And the same thing will be actually implied here if we go back up on section 2. Uh, yeah, one step up. Yeah, so you go to Colombo, and this one is step 2. So in nutshell, you can actually go to machine learning, and then to step 3, for example, you have everything in a form of Excel sheets. Right, so far so good. So let's go back to the demo, to the presentation. So what is the pros and cons of Colombo? First of all, it makes as you've probably seen by now, that makes the investigation process easier and faster. And if you get a huge amount of you don't have to have so many windows up and running or running commands. You just say yes or no, and just put some process IDs, and you're off. You're to go, ready to go. And it can assist the examiners by providing suspicious and genuine. Again, these are strictly to assist the examiner on their decision making. It can produce percentage or likelihood or certainty, if you want to call it, to minimize false positives. It produces grouping and traceability and all that. And you've actually seen this in the ransom example, how you can actually go back and trace it back to the mother process or processes. The downside of Colombo, it relies on third-party tools, for data generation. In another word, we're using volatility, auto runs and other third-party applications in order to extract the data. I was asked, why are we doing this? Well, I mean, I don't need to reinvent the wheel again, because you have these tools to extract the data. I would like to focus on identifying the executables, the commands were involved, all the other, identify the evidence instead. Models need to be retrained. I'm in a process of, improving that part. So the user they can have the option of using a pre-trained model, or you could actually use your own data to train it. And I'm sort of making a framework where users can actually train their own data, or train it on top of the existing models that we have. That's something that's on the to-do list, and I'm working on it. Again, false positive, there's not much we can do apart from providing, percentage values and improve the model with new cases, and this to increase the accuracy. If you want to download it, you go to this GitHub, Visma product set, Colombo. Thank you very much for providing that link. And this is where you can download it. Is it me? Yeah. Now, one of the most important things when it comes to machine learning in general is you get biased models. And initially, the reason I didn't provide a framework for people to retrain or train their models according to their needs is because of the lack of knowledge when it comes to machine learning, and how a model can actually fool the user to believe this is correct or genuine rather than suspicious. So when I did this training process, I used different learning algorithms, from logistic regression all the way to neural network, using cross-validation and accuracy. I got these results. When you look at the output, we get 89% accuracy. So 89% accuracy means the model is doing perfectly great, and it's accurate by 89%, or safely say 90%, at least with these learning algorithms. But as a machine learning practitioner, this is not good enough, because you want to know whether the model is actually fooling you or not. In another word, the model has been overfitted. Simply put, it has whether the model has memorized all of those behavior, whether the model actually learned all of those behavior that we talked about. And this is where you apply other statistical approaches or mechanism. One of them is called confusion matrix. The other ones are called precisions or recall. So what you do, you take each, behavior, binary behaviors, and you try to figure out whether, the accuracy or the value of it is high or small. So 0 here means, in this part, what we mean that the model is doing great, 95% detection of all the genuine behavior, but 61 detection when it comes to suspicious behavior. In another word, the model is doing perfectly great by 95 or 94% identifying zeros as zeros. In another word, normal behavior as normal behavior, while doing really not that good when it comes to identify suspicious behaviors as suspicious behaviors. And in machine learning, or in the world of sort of data, we call this the data is actually an imbalance. In other words, the model, the data that we have more normal behaviors than suspicious behavior. And as a result of that, the model becomes biased towards normal behavior. Anything that it sees is suspicious. Anything that it sees as normal. This is a bad, or really can be scary. For example, when it comes to facial recognitions, if you want to find a criminal, if you have a biased or imbalanced data, chances are you have a wrong detection. You might identify a genuine person to be criminal, and you take that person to custody. So it's very, serious matter. And this approach can be used by attacker in a context of data poisoning, to fool the user, oh, this is normal, even though it's not, it's suspicious. So what we need to do, you need to balance out the data. And I increased the amount of suspicious cases or events to sort of, get close enough to be balanced enough. And as a result of that, we can see a great improvement in models identifying zeros as zeros and ones as ones, and the confusion matrix have been improved quite well afterwards. And as a result of that, the accuracy using cross-validation for nearly 8,000 cases have been improved. Right, so these are very important. If you want to build your own models, you need to really consider all of these things. Imbalanced data, bias, overfitting, underfitting. These are things you need to put it under consideration when you build your own model. And we tried as much as possible, where applicable, to improve these behaviors. But on daily basis, we get new events, new behaviors, which I use it to retrain the model and tweak it accordingly. Nevertheless, it's nearly impossible to reduce the false positives or wrong detection. That is, it cannot be done, mathematically speaking. Right. Now, I hope you enjoyed the session. If you have any questions, I'm more than happy to answer. And if you want to contact me afterwards for any questions, given my contact information, I'm more than happy to answer privately as well. Anything? Okay, I take it this was either very boring or very difficult.
People always remember the good questions afterwards, well.
Okay, sorry, I don't think I hear you.
Okay, so there's no questions at this point, it seems.
Sorry, I apologize, but I don't think I can hear you. Not to. Oh, well, explain this. Yeah. 1 second. Yeah. Can you talk? I can hear you.
Okay, I'll try to say something again. Can you hear me now, Alan?
Yes, I can. I apologize.
Perfect. Okay, I was just saying that if someone has any questions later on, you will provide them with your contact information.
Yeah.
About what is the best way to reach you. And the Hackon team would like to say thank you, Alan, for this great talk about machine learning used in computer forensic. And thank you
Thank
for
you.
showing us Colombo live. That was great, Alan.
Thank you. Well, have a good day. Thank you. Bye-bye.
Thank you. Bye.